going to walk you through the steps on how to do a beam deflection study in Fusion. So the first thing we're going to do is make sure we go to our document settings. We're going to want to have for our study our unit in inches. So I'm going to make sure my unit is in inches. I'm going to go ahead and click to create a sketch. I'm going to choose the plane to create the sketch on. And we're going to start by creating a rectangle at the origin. We're going to do this study on a 2x6 beam. And so within the dimensions, I'm going to go ahead and type in 6 for the height of the beam and 2 for the width of the beam. When I have that done, I'm going to go ahead and click Finish Sketch to finish it. I'm going to go ahead and click the Home tool. And then we're going to make the beam 8 feet long. And so in the dimension for the extrusion command to make the beam 8 feet long, I'm going to type in 8 times 12. And that will give me a 96-inch beam or an 8-foot beam. When I have that done, I can go ahead and click OK. The next step is going to be to go to our simulation workspace. And so under the design, I'm going to change that to simulation to get my simulation tools to come up. We're going to be doing a static test here. There are many different types of simulations you can do in Fusion. We're going to be doing the static stress. So I'll go ahead and click Create Study. From this point, we're going to need to define the material that our beam is made out of. So under Materials, I can go ahead and click Study Materials. It'll bring up a box where I can choose the material that I want. Right now, it's same as Model. So whatever the material was when I modeled it, which was the default, I can do that and leave it. There's also all these built-in materials into Fusion that you can use. For this example, we're going to be using ABS plastic. So I will go ahead and choose ABS plastic and click OK. Once I have that, the material of the beam has been changed, so now it can do a study on the beam. If I go back to the material and I select Study Materials and click the little Edit button here, you can look at all of the properties for those materials by clicking Properties. And so if I look at the study material of ABS plastic, I can click on the properties for that of the ABS plastic material. And once I have it selected, I can see all of the material properties. So Young's modulus, yield strength, tensile, so all of those numbers are right here. The next thing we're going to do is add some fixed points to our beam so that we know where the fixed points are so that we can load the beam and do our study. So I'm going to go ahead and click on Constraints. There's different types of constraints that you can choose. We're going to be using fixed joints for this study. So I'll go ahead and make sure Fix is selected. And then on my target, when I select it, I'm going to select this outside edge. And I'll go to the other side of the beam here. And I'll select that same edge on the other side of the beam. And go ahead and click OK. And what we're doing is saying those points are now fixed in the study that we're going to be doing. The next thing that we have to do is add our load to our beam, and so I'll go ahead and click Load. Again, many different types of loads you can add for your simulations. I'm going to go ahead and click a force. And then I'm going to select the top surface of the part. So I'm not selecting an edge, I'm selecting this whole surface. When I do that, you'll get all of these arrows that show the load that we're putting on. In this case, this is a normal load, and so that means that force is normally distributed across that entire surface. For our case, we're going to use a vector in the direction type. So I'm going to go ahead and click on vector. Under units down here, I'm going to go ahead and change the units from newtons to pound force. And then I'm going to choose the direction that I want that pound force. So notice I have 3 boxes, the X, Y, and Z axis. And depending on how you modeled your part, you can see that that would put the force on the side of the beam, which is not what we want. If I choose the Y, puts it on the other side. So again, not what we want. You can see if I put the force in the Y and the other ones are at 0, I get my force, but notice that the force is going up. We want it to go down into the beam, and so I'm going to have to type in negative to change the direction of that force. Once I have that done, I can go ahead and click OK. Right now we have our 8-foot long 2x6 beam made out of ABS plastic, and I'm going to go ahead and select the solve button. When you do that, you'll get a little prompt that comes up. You can select that and then select to solve your study. You'll have to save this first, so you can go ahead and save that into your folder. And then the study will start. The study will take several minutes to complete, so just let the study run. Once the study has completed, you can go ahead and click close, and you can see the results of the study. I'm going to go ahead and click to look at this as the right side view. If you look at the different aspects over here, you can see that the safety factor is what's selected now. So there's different options. What we're interested in right now is displacement. So I'm going to go ahead and click on displacement. And then under the unit, I'm going to click on, and I'm going to change that to inches so we're in the same unit. And so what we have learned about this beam here is that it has been displaced 100 thousandths of an inch. So you can see that here. And now I'll go ahead and select Finish Results, and you can see that it'll take you back to your original beam. To view those results, you can just click View, and the results will come back up for you to view. One last thing to look at is if you look at your result details, notice that the deformation scale right now is set at adjusted. So if you think of 100 thousandths of an inch, that looks way more than 100 thousandths. That's because the deformation scale is adjusted. So if you select that, you can say you can choose how you want to view it. And so if I want to choose the actual deformation, you can see that the actual deformation, you have to zoom in very far to see that because it is such a small deformation. And so again, you can adjust that factor by 2 times, by 5 times, just to help you visualize the effects of the beam. And so that's how you find displacement and the deflection of a beam within Fusion.